Hello my friends, and welcome back to another lesson in Algebra 1. And so today's lesson is about linear regression. And the cool thing is about a linear regression is that we can do so much of this, practically all of it really, on your calculator. So like my sloth over here, she says, you know, technology really helps and you got this. And so make sure you are using your calculator because it is going to help you out tons. So this is Unit 5, Lesson 16. This is the last lesson in this particular unit. And what you're going to do is you're going to use your graphing calculator to find a thing called linear regression for a set of data. And when you do this on your calculator, it's going to give you something called a correlation coefficient, and that will help you know the relationship between the variables. So when you are done today, that's what you should be able to do. Use your calculator, get your linear regression, find your correlation coefficient, and be able to tell me what that means. So because we are on the computer, we're going to do Desmos, but I also put directions in here for TI-84. We're only going to worry about Desmos right now because, hello, that's what we're on with. We're on the computer. So I will show you and walk you through how to do all of this here when we get to it. Let's do just a tiny little bit of notes and then we'll go solve some problems. Okay. So my correlation coefficient, it's used to show the strength of correlation between two variables. And it's got the super fancy, amazing abbreviation R. So R stands for correlation coefficient. And so your calculator will give you R. You don't have to do the magic yourself. Your calculator will do this. Now, in the last lesson, we found the line of best fit by hand. It was tedious, it was drawn out, and it was also prone to human interpretation and error. So if, you know, two or even a whole class of people found the line of best fit, depending on how they looked at that data, their line might vary just a little bit one way or another. But this, what you're going to find out is the calculator is going to tell you. So there really is only one right answer. Whoops. So let's go ahead and let's look and see what all of this stuff means. Now, if we looked at this particular set of data here, it is a bunch of kind of nonsense. There's no clear relationship. And so it's got a number, an R value, a correlation coefficient of 0. It makes sense. There's 0 sense making here, right? Like the dots are everywhere. So its correlation coefficient is 0. Now, if it is a perfect correlation coefficient, you have two options. You can have a perfect positive situation where your number is a positive 1. Okay, this is where the numbers go up together and it's in a perfect line. Everything's just perfect. Okay, now, but take into effect, you do have negative relationships in negative, even though we tend to think of negative as meaning something bad. All this means here in this case is that the number is going down. Okay, so as this particular number is going up, this number is going down, so we've got a negative slope. If it is a perfect negative relationship, it's going to have a R value of negative 1. So this is a very strong relationship. And this is a very strong relationship. And so you go from the perfectly positive to the perfectly negative. Both relationships are equally valuable because they're really just showing a different situation. So the closer you get to either a positive 1 or a negative 1, the stronger the relationship. But the closer you get to 0, this is no relationship, none. Okay, so let's look at this moderate positive and weak positive. You can look at this one and you see you got some dots above and below. Okay, so it's not perfectly linear like this one. It's a little more loosey-goosey. And so it's a moderate positive, and it might have a number like 0.8. And that relationship can get even more scattered like this, where it's still got a positive relationship, but, the dots are a little bit more spread out. And so a weak positive might have more like a 0.3. The same thing is happening over here. We can have a weak negative, and that's going to be negative 0.3. And we can have a moderate negative, and that's going to be a negative 0.8. And then we've got a perfect negative, which is negative 1. Okay, so if you need to pause it, of course, do that. I'm going to go ahead and scroll on down. I'm going to erase this little extra spare line. It's really bothering me. Okay, I'm going to scroll on down. And if you need to pause it, please do. Okay, so this one, it shows, so we've got a data table over here. We've got weeks and weight, and this is a puppy's age. And it's weight as it grows. What is the correlation coefficient, and what does it mean? Well, let's stop and just kind of think about what's happening. When a puppy's growing, we expect it to gain weight. Like that is that's just what we expect it to see. It's going to get bigger, it's going to get heavier, and so we would expect a positive correlation coefficient. It's going to do something more like, over in here, this one or maybe this one. We're going to expect something like that because we do expect a puppy to gain weight as it grows. Well, all we're going to do to solve this is we're going to take these numbers and we're going to put it in our calculator. So let me go grab my Desmos real fast. And we will put this in. I'm going to go ahead and exit out some of my other stuff that I did here, so we get a nice clean slot. Okay, so what we're going to do is we're going to hit this little positive here. And we're going to pick the table. So I'm going to enter these numbers in real fast. We've got 0, 4, 8, 12, and 16. So those numbers were the weeks of our puppy. It was at birth, and 4 weeks, 8 weeks, 12 weeks, and 16 weeks. So we went from 4.5 pounds to 6.2, 8.1, 9.7, and 11.3 with your puppy's weight. Okay, yay, we put this in there. Now what? Well, let me just show you over here. Remember, it tells us to use this button. Okay, so we did this. We hit the positive sign, we put in our table, we entered our values. We're going to hit this button here, okay? And it's going to do the magic. Okay, so my button is right here. So we hit that, and we get all this mess. What is this mess? Okay, so this is my equation, and I wrote it down on my paper ahead of time so I can just write it over because I'm never going to remember that. Notice we do have a positive slope, so that's telling me that your puppy's gaining weight every week. And this is my correlation coefficient. Do not worry about this r squared. Okay, so no, don't worry about that. The one that we want is this. Yes. Okay, we want just the plain r. So we're going to get our equation. We're going to get our r value, and we're not going to worry about this number here. Okay, so let me go write that down. So my correlation coefficient was r is 0.995. So what does this mean? Well, look, this is very close to a perfect positive relationship, right? It's very close to a 0.1. So this is going to be a, strong positive relationship. And because we're talking about a puppy here, we can put it in puppy terms. The puppy gains weight every week. Okay. Now, this relationship would not be true once a puppy reaches adulthood. You know, they're not going to gain that same amount of that same amount of weight every week because they're going to be grown. And so, you know, they might gain weight once they're grown, but it's not going to be the same kind of relationship. So this won't continue forever. So we just are looking at it, you know, in this one small terms. Now, let me draw a box around this. So this was my correlation coefficient. And so write the equation, the line of best fit. It's the, you know, we got it straight from our calculator. I just wrote it on my piece of paper ahead of time so that I could make sure, because otherwise I would never remember this. So I just want to point out the puppy is gaining, you know, 0.4275 pounds a week. That's what our slope's telling us. Okay, so that's just kind of a little side note, a little side jog there into slope. That's what that's telling us right there, is that it's gaining that much per week. All right, it didn't ask us that. That was just a little bit of bonus information because, you know, reasons. I just decided to give it to you. Okay, they want you to predict the puppy's weight at 40 weeks. Okay, so my weeks over here, this is my x, my y is weight. So that's what my equation's telling me, is my y is weight and my x is weeks. So in this case, my x value is going to be 40 weeks. So let's plug this in. So we got y equals 0.4275 times 40 plus 4.54. Let's go put that in our calculator. That's a lot of decimals to do by hand. We're just going to do it on our calculator because, yeah. Okay, so move it over here. I'm going to type it in down here. Oh, and see, look, you can see again, you know, just to point out, like that equation we wrote down, that equation we wrote down, we wrote straight from our calculator, right? So let's see. This is 0.4275 times 40 plus 4.54 equals, and that's 21.64. So my y is going to be 21.64 pounds at 40 weeks. Okay. We would expect that puppy to be done growing, you know, by this time. They might fill out a little bit more, but they've definitely passed through that fast growth of puppyhood. Okay, let's look at the next one, and let's think about what's happening here. And here again, if I'm going too fast, just pause it because, of course, I'm recording ahead of time. So this one shows a car's depreciation. Let's think about what that word depreciation means. That means the value goes down. Okay, so as something like a car or a computer, if you buy it, its value is just going to keep going down. It doesn't typically go up. And so we're going to expect to see more of a relationship somewhere over here. Okay, it's going to be in these negative ones. The value is going to go down as it gets older. So, and we can see that here. It gets older and then the value is going down. We're going to go put that in our calculator. Let me just finish reading what it's asking. It's asking for the correlation coefficient and what does it mean. Alrighty, let's go grab our calculator and put this in. I'm going to exit out of this other stuff because, yeah. Okay, so our car, so I'm going to hit plus here, and I'm going to pick the table. So our car, when we first bought it, we paid, you know, $22,000 for it. But, you know, as time goes on, it is going down in number. So again, I am going to do the magic over here. I'm going to hit this add regression, and boom, this amazing thing happens. Okay, so let's get our numbers here. This is my equation. We can see that it has a negative slope, and this is my r value. I'm not going to worry about that r squared. Okay, so I'm just going to grab my r value. Okay, now I wrote this on my other page, so I don't have to look at my calculator. I'm going to go write that down. So my correlation coefficient is negative 0.9984. And so it is that negative relationship. In fact, it's a strong, practically perfect negative. Okay, our data is going to be doing this. So what does this mean? It means as the car ages, its value goes down. And this is why also, you know, people will end up keeping their cars until they just die. Like, try to keep it, you know, as long as you can, because cars are expensive. And so they always go down in value. So you're going to pay more for it, and then it's going to go down as it ages. So it really doesn't make sense to keep buying a new car every year, you know, financially. You know, might as well just like use it until it's gone. All right, so the equation of the line of best fit, we wrote it was y equals what? Negative 1740. So that's my slope. And then my y-intercept is the 21,733.3. So what this is telling me is my slope is telling me that it goes down, $1,740 every year. Okay, that's what my slope's telling me. All right, so there's two questions here. I'm going to kind of break it up where this side over here, I'm going to do this part. So we're going to say the value after 8 years. Okay, so my x is my years and my y is my value. So this is asking what my value is when x equals 8 years. Okay, this is why data is good to have, because we can model what would happen. The 8 years is not listed here, but we can make a prediction of what its value would be. So I am just going to plug in my 8 years. I'm going to write my equation over again. I've got negative 1740 times 8 plus my 21,733.33. I'm going to grab my calculator and drop those numbers in. Okay, so we got negative 1740 times 8 plus 21,733.33, and that's going to equal 7,813.33. So, you know, the car will be worth $7,813.33 after 8 years. Okay. We can draw a box around that. Okay, I'm going to go ahead and switch color so we can look at this one. It says, when will the car be worth 10,000? Okay, I want you to look over here. My dollars, that's all this. So that they gave me a Y value. So it's like saying, when will Y equal 10,000? So you got to be careful when they switch up these numbers like this. Are they giving you an X or a Y? We got to think about what those numbers are telling us. Okay, so we're going to use the same equation, but we're going to put 10,000 in here for Y. And then we're going to need to do a little bit of algebra before we can drop it into our calculator. So I'm going to get my 21,733.33. I'm going to subtract that to the other side. Okay. And so let's see, that's going to cancel out there. 10,000 minus 21,733, that's going to give me negative 11,733.33 equals negative 1740x. We got to get rid of that coefficient in front of x, so I'm going to divide that out. Negative 1740. And then it's going to give us our x value. Okay, so that cancels. Let's go drop that number over here into our calculator. And we'll put it over here. Okay, so we got negative 11,733.33 divided by negative 1740, and it gives me 6.74. And we could even round that to tenths of a year because, I mean, 0.74, that's a little, so we can put 6.7. Okay, so it at 6.7 years, the car will be worth, and I'm just going to write 10K. Okay, so at 6.7 years, it's going to be worth 10K. That's what our data is modeling. Okay. Alrighty, my friends, all the practice problems are like this, where you are going to be putting the data in and getting what the calculator tells you. Until next time, bye.